So, good afternoon, everybody. Myself, Acharya Vishvendra. Let's discuss the photoelectric effect today. So, for the first thing is observation. So, it was observed by uh, scientists that when energy of photon is greater than a certain particular frequency energy, then certain photons are emitted from the surface. So, this minimum energy is called the work function of that particular metal, which depends on metal and the nature of its surface, and it is called the work function or the threshold energy. So suppose this is a metal surface, photons are emitted on it and there are electrons. So this work function is minimum for cesium and maximum for platinum, which means it is easiest to take out electron from cesium, while it's the most difficult to take out electron from platinum. Now, work function has the same dimension as energy and work and torque, which is ml to t minus 2. SI unit is joule or kg meter square second minus 2. Working unit is electron volt. CGS unit is erg or gram centimeter square second minus 2. Now, 1 electron volt is 1.602 10 is to power minus 19 joule, and 1 joule is equal to 10 is to power 7 erg. Now, the second point regarding photoelectric effect is that photoelectric effect takes place only when frequency of photon is greater than a certain minimum frequency, which we call as the threshold frequency, and it depends on metal and nature of its surface or work function. So energy should be greater than threshold frequency. That means h nu is greater than phi naught. That means nu is greater than phi naught by h, and this phi naught by h we call as nu naught. Obviously, it depends on phi naught, which again depends on metal and the nature of its surface. So that's how threshold frequency is related to metal and its surface. Now let's see some graphical analysis. So we can say that threshold frequency is equal to phi by h. So graph between threshold frequency and work function is a straight line. Suppose here the slope angle is theta. So we can say that on increasing work function, threshold frequency increases, and with decrease it decreases. And for slope we can use tan theta is equal to y by x. So it's v naught by phi naught, which is 1 by h, which is a constant for all gases. And one thing is there that work function and threshold frequency is minimum for cesium and maximum for platinum. Now another case is energy greater than phi naught. So energy can also be written as hc by lambda, which is greater than phi naught. So hc by phi naught greater than lambda. That gives lambda less than or equal to hc by phi naught. We call hc by phi naught as lambda naught or the threshold frequency. So we know that lambda naught is inversely proportional to the work function. So with increasing work function, threshold wavelength decreases and vice versa. So we can say that lambda naught is minimum for platinum and maximum for cesium. Now, it was also observed that photoelectric effect takes place only when wavelength is less than, obviously, as per the energy considerations are there, wavelength of the photons has to be less than the threshold wavelength. So that explains it. Let's see some graphical variations of threshold wavelength with work function. It's like this rectangular hyperbola graph, whereas with 1 by phi naught the graph will be a straight line. And if we calculate the slope angle over here, it will be equal to hc. Now there is another question that three metals are given, they have work functions as 3, 4 and 5 electron volt respectively. Then we need to find work function in joule. So 1 eV is equal to 1.6 into 10 is to power minus 19 joules. So in this way we can calculate work function in joules. Next, threshold frequency. So work function is h nu naught. From here we can calculate nu naught. Then threshold wavelength, using the concept that c is equal to frequency into lambda naught, we can see the threshold wavelengths over there. Threshold wavelengths in nanometer, we can convert that. Next is in angstrom, again we can use the conversion factor. Next is which metal has maximum threshold frequency. So threshold frequency is directly proportional to the work function. So metal C is gonna have maximum threshold frequency. Similarly, A has minimum threshold frequency. Next, maximum threshold wavelength. So it is inversely proportional to the work function. So metal A's have maximum threshold wavelength, whereas C has the minimum threshold wavelength. That we can solve easily. Now there is a question that spectrum, that all the photoelectrons emitted have a spectrum of the speed and kinetic energy, and the kinetic energy of the photoelectrons emitted lies between 0 to a maximum value, which we call as the Kmax. Now, for calculating Kmax, we assume that there is interaction between a photon and an electron. So the total, from conservation of energy, we can say that energy of photon is E, and we assume that energy of electron is 0. So that is 5 plus Kmax. So from here E is equal to 5 plus Kmax, and Kmax comes out to be E minus phi naught, where now the kinetic energy of any electron lies between 0 to Kmax. Here it should be noted that why there is a spectrum of kinetic energy or speeds, because as you can see over here, when the photons will strike the metal surface, then the most probable, or the, you can say that luckiest electron is that one which does not collide with other electrons in the crystal and just comes out without any interaction. So that will be having the maximum kinetic energy. But generally what will happen is, when this photon will interact with the electron, then after absorbing the energy, this electron will collide with other electrons, and in that collision it will certainly lose some electrons, some energy, sorry. That explains for the spectrum, and the minimum energy that it can have is 0. It is for that with the bad luck, and the maximum possibility is that it can lose all of its energy. So that explains why maximum kinetic energy, or kinetic energy, lies between 0 to Kmax. Now let's see the graphical analysis of things. So Kmax is E minus phi naught. If we compare it with the standard equation y is equal to mx plus c, we can say that m is equal to 1 and c is equal to minus phi c. So that is going to be the graph. And when Kmax is 0, the energy corresponds to the work function, and here it is minus of phi naught, as given by the slope, as given by the intercept over here. Now let's analyze the entire results for two different metals. Suppose there are two metals A and B. Angles are theta A, theta B. These are the intercepts. So from the graph we can analyze that both of angle are equal and equal to 45 degree. Then, as evident from the graph, work function for B is greater than that of A, which means threshold frequency of B is greater than that of A, which again explains that threshold wavelength for B is less than that of A. Now is the question that graph between Kmax and frequency of photon. So Kmax is E minus phi naught, and we can say that E is equal to h into nu. So that is again going to be a straight line, just like this. And here tan theta is equal to h, which is constant for all. Now let's compare the graphs for two different metals. Suppose there are two metals A and B, angles are theta A, theta B, and the corresponding intercepts are phi naught A, phi naught B over here. So from the graph we can say that phi naught B is greater than phi naught A, as it is evident from the graph. Phi naught B is more than that of A. So larger the threshold frequency, larger will be the work function, and smaller the wavelength. So that is going to be the pattern between A and B itself. So we can say that graph between maximum kinetic energy and frequency is a straight line having its slope equal to Planck's constant, and intercept is equal to minus of phi naught, where phi naught is the work function of the metal. So for different graphs, we can say graphs will be parallel, but different intercepts will be there. Now there is another question on three different metals A, B and C. These are the frequencies, and the unit here is 10 to the power 15 hertz. Then first of all we need to find phi A, phi B and phi C. Sorry, theta A, theta B and theta C, the angles. So angles are equal for all, so that will be 1. Then we need to find relation between the threshold frequencies. So obviously this point corresponds to the threshold frequency. So for C it is greatest, then B, then A, we can say that. Then is the work function. So obviously C is gonna have maximum work function, then B, then A. Wavelength is in the inverse order, so wavelength, threshold wavelength for A will be greatest, then that of B, then that of C, that we can calculate using these. Next is graph between Kmax and wavelength of photons. So we know that Kmax is E minus phi naught, E is hc by lambda. So the graph here will be like this. So first of all let's draw the graph between Kmax and lambda, 1 by lambda. So treating 1 by lambda as x, we can say that slope is equal to hc and c is equal to minus of phi naught. So the graph will be like this, and m will be tan theta is equal to hc, and theta will be tan inverse of hc, which is again a constant. Now there is one question that if we draw graph between two different metals, theta A and theta b, intercepts are these, then we can analyze that both angles will be equal, as they just depends on h and c. Whereas we can say that 1 by lambda naught for b is greater than that of 1 by lambda naught a. That means lambda naught a is greater than lambda naught b. That means threshold frequency is greater than that of for b as compared to a. And when threshold frequency of b is greater than that of a, that means work function for b will also be greater than that of a, and lambda naught obviously follows the inverse order. Let's discuss another question. It is on the three graphs between kmx and 1 by lambda for three graphs. So the first question is the relation between theta a, theta b and theta c. So obviously all the three are equal. Then we have threshold wavelength. So that will be greatest for 1, as 1 by lambda is greatest for the third graph. So lambda follows the inverse order. So lambda naught for 1 will be greatest. So that means uh, 1 by lambda naught is greatest for third graph, and 1 by lambda naught is proportional to frequency, and frequency is proportional to the work function. So we can say that work function for 3 is greater than 2 is greater than 1. Similar for the frequency, and inverse order for the wavelengths will be there. Now there is which graph has maximum work function, obviously C, maximum threshold frequency, obviously C, and maximum wavelength, it is corresponding to the first option. Now, so these were some of the questions based on the quantum theory of light. With practical applications, we discussed the idea of kmx, why there is a spectrum of kinetic energy. We solved different questions based on the graphs, different probabilities, different permutations and combinations, relations between threshold frequencies, wavelength, work functions, and these are just I tried my best to use maximum permutations and combinations so that you can interrelate the different concepts and can perform better in your exams. Thank you and have a nice day.